Okay, so in this section, two things we're going to look at. We're going to look at receptors and how not only do we send impulses down neurons, efferent neurons to muscles, but we also have information coming from the periphery, from skin, from other places, sending impulses to the central nervous system. And we're going to look at that and how that plays a role in function and performance, which we'll look at. And then we're going to talk about two other aspects of the nervous system which are really important: parasympathetic and sympathetic, and their role in activity. So sensory receptors, we have literally millions of these in our body. Any nervous tissue that can send impulses, afferent impulses, back to the central nervous system. These can be thermoreceptors in your skin, nociceptors, which sense pain. We have light receptors, mechanoreceptors, which we're going to talk about here. Receptors in your tongue. I just had a bloomin' onion from Outback, yummy. So it's sending impulses to my brain. Just, oh, really awesome stuff. So we get the idea there. Mechanoreceptors or proprioceptors, these are the ones we're going to focus on because they have a key role in movement. They provide information to the central nervous system, making it aware of the surroundings. And these receptors make note of where your body is, where joint angles are in proportion to the environment. They even send impulses when you're walking to the feel of the ground. Is it soft? Is it hard? Is there gravel? Things like that. And then your central nervous system then sends efferent impulses to deal with that. And so these proprioceptors play a huge, huge role in how we perform, how we function, how we interact with our environment. And they also play a role in reflexes. And reflexes, when it comes to performance, is really, really key. So let's talk about reflexes a little bit because how these occur literally every day. Now, when we think of reflexes, it's easy to say, reflex is a reflex action where if someone, scares you, you run. Or if you see a bug, you smash it. I don't know. Those are reflexes. And in a sense, those are reflexes. But what we're going to look at here is the actual nervous system pathway that's causing this resultant muscle contraction. And what's so amazing about reflexes is that they have to be so quick and so fast. They don't even involve our brain. And I think we get that because you don't think about reflexes. You don't think about squashing the bug or running from whatever. It naturally occurs. And what's so amazing, as we'll see here, is that in these reflexes, and this is an example of one, where we have something occurring. Let me move this up. Yeah, let's move this over here. We have something occurring. So this is touching a pin. That hurts. That is going to send a afferent depolarization impulse up to the spinal cord. There's then other interneurons here that also depolarize, and then without even going to the brain, just right back down, this is going to send an efferent action potential down these neurons to these muscles to tell them to contract. So the brain's not even involved. How awesome is that? Now, it would be awesome, to be honest, if every muscle contraction we could do like this. It would be nice. Some things do them really quickly. How many of us would like to, run faster or do things so quickly our brain doesn't have to think about it? So reflexes play a key role. The speed of these reflexes, how well they function. Truth is, in training and activity, we actually use this because we want to develop muscle patterns that literally become reflexes, things we don't even think about. And so when we think of reflexes, you may think of a pin or putting your hand in the fire and pulling it away. But really, reflexes are activities that we engage in that less and less requires central nervous system activity, at least brain activity, that we can use potentially reflexes for. The more and more we can move activities to this type of pattern, the better. Now, there's negatives to this, okay? In some activities, we need to have upper brain processing. We need to be aware of an environment. We need to think through and engage in some cognitive processing in regards to the reflex. But this gives us some idea that, yeah, reflexes have a value here, and it's not just, dealing with putting your hand on fire or something like that. And so these reflexes are key to performance. Now, this becomes key because when we talk about muscle, which we'll get to in a couple classes, there are neurons that innervate, that connect to muscle cells. And we typically call this interaction, this group, a neuron, and all the muscle cells it innervates, we call that a motor unit. And this is key because it's not one neuron to one muscle cell. If it was like that, you'd have way too many neurons. You would just be this thick neuron that just wouldn't work. So we have typically one neuron to some number of muscle cells. We call that a motor unit. Some of those ratios are large, where we might have one neuron to 50,000 muscle cells. Some are smaller, where we may have just one neuron to maybe a few hundred muscle cells. And you can think through it and maybe try to guess what's the value in having smaller motor units, smaller ratio motor units. What's the value in having larger ratio motor units? And can you guess what muscles may tend to have larger motor units and what muscles tend to have smaller motor units? So think about that. We'll get back to that at the end. So motor units plays a role here. We'll get to that when we talk about muscle function and how muscles contract. The last thing I want to look at, we're going to leave sensory and reflexes, sensory neurons and reflexes, and move back to different parts of the nervous system, because there are things that our nervous system engages in that are not in our control. We call those autonomic. For being able to throw a ball and run, which we can think about, combing our hair, we think about. There are things that our nervous system engages in that we don't think about. Heart rate, breathing, blood pressure. Those are autonomic functions. Now, yes, those are partially under your control. You probably can slow down your breathing and slow down your heart rate, but at some point you pass out and the body takes over. So the nervous system, there's an autonomic aspect to this, and we generally divide this into sympathetic and parasympathetic. Now, I'm not going to go through each of these different parts here, looking at all the specifics in sympathetic, all the specifics in parasympathetic. Let me make it real general. Think of sympathetic as all the things getting the body, getting cells, getting tissues to engage in activity. Increasing heart rate, blood flow to muscles, increasing airway diameter, increasing metabolic rate, increasing mental activity. Think of parasympathetic as kind of the opposite of that. When we need to rest, when we need to slow engagement, when we need to digest food instead of utilizing, we need to decrease heart rate, decrease diameter, there's the parasympathetic nervous system. And understand, this is not sympathetic good, parasympathetic bad. These both have to occur. If we live in the world of sympathetic nervous system and we never have parasympathetic, we call it stress. We call that being overstressed. We need parasympathetic for growth, protein synthesis, things like that. Likewise, we need sympathetic to, be alive and do stuff and be alert and watch these videos and somehow, stay awake through them. And so we need both of these sides. Now, this picture kind of gives you a more specific organ to organ, tissue to tissue perspective of what this looks like. You can read this on your own. But it gives you an idea that both of these exist, and the central nervous system has neural pathways to each of these tissues, organs, to engage sympathetic and parasympathetic nervous system activities. And the last slide here, this again just kind of goes through a list of these. You can look at that on your own. I want you to make sure you know the difference between these two, what they are, what are some activities that are in each of these. These become important because when we start to talk about the endocrine system and its role in exercise activity, that is very much predicated on the nervous system and its function and sympathetic versus parasympathetic activity. We can make the same argument for the immune system, which we'll go to later on in the semester. And so distinguishing these two aspects of the nervous system is key. Okay, that's it for this lecture. We'll see you in class.